Okay, this is 6.3, applications of linear equations. So we've worked with linear equations, right, in 6.2. So now we are going to construct these algebraic equations or mathematical models, is another way of saying that. So example 1, the average yearly salary and actually this problem is, it's actually number 21 in your book on page 374. And there's a nice bar graph there. I had trouble uploading it, but if you want to look at the graph, it's helpful, but we don't need it. Okay, so the average yearly salary of an American whose final degree is a master's degree is 49,000 less than twice of an American whose final degree is a bachelor's degree. Okay, so we're talking about average yearly salary of someone with a master's and someone with a bachelor's degree. Combined, okay, important word, combined, two people with each of these educational attainments earns $116,000. Find the average yearly salary of Americans with each of these final degrees. Okay, so we're given a lot of information. So now let's break this down. So I kind of wrote the steps out for you. I think it's just a nice skeleton, especially when you're first learning to construct these models. So step 1, what is the unknown? Okay, in other words, what don't we know? What are we trying to find? And then we want to define it, right, in terms using a variable, just so we don't have to write the whole sentence every single time. And usually step 1 is the last sentence of the problem. And the last sentence says, find the average yearly salary, right, of Americans with each of these final degrees. So we're finding there's two unknowns actually. One of them, right, is the average yearly salary of somebody with a bachelor's degree, and the second one is an average yearly salary of somebody with a master's degree. So I'm going to let X, right, it's a T, be the average yearly salary somebody with a, so let's just say bachelor's degree. Okay, and I'm gonna stop there for this step. Okay, and I'll explain that in the next one, but I'm just gonna underline that, so I'm gonna refer to that. Okay, step 2, if necessary, write expressions for any other, okay, other unknowns or other unknown quantities in the problems in terms of x. Okay, in terms of x, well, we just defined an x right here. So now we can write another expression, right, that has that x in there. That's what in terms of x means. So let me just change my color for masters. Okay, so if we go back to the beginning of the sentence, or the first sentence, so the average salary of an American whose final degree is a master's degree, okay, so in green, is 49,000 less than twice that of an American whose final degree is and then in blue is bachelor's. In order to define the master's, I had to define the bachelor's degree. So this is our other unknown quantity, is going to be, just draw a little arrow. So the master's degree is going, so let's see, then twice of an American whose final degree, okay, is a bachelor's. So let me, so 49,000 less than, right, that's this part right here, twice of an American whose final degree is bachelor's. So twice what? Well, twice what we have above, right, which is x, right? So we have to use that x. So this guy is, let's see, let me go back to green. All right, so this is, I'll just write these quotes. So average yearly salary of an American with a master's degree. Okay, so that's step 1 and step 2. And again, this, it's already a couple points by writing this in. Step 3, and let me just go back. I'll go back to blue. Okay, so write an equation in X, right, that models this situation. Okay, so what do we have? What are we talking about? Well, step 1 is the average salary of somebody with a bachelor's degree. So I'm going to basically use step 1 and step 2 to get step 3. And I also have the master's degree, and that's 2, and I'll just wait to change that X with a blue. Okay, so 2x. So I have this quantity and I have this quantity, right? That's just, again, step 1 and step 2. And notice above, right, that, let's see, the second sentence, it starts with combined, right? If we combine these two salaries, so combine meaning plus, we get how much money. Well, they give us it's right here. It's $116,000, right, combined. So that's our mathematical model. So now let's go ahead and solve it. So let's see, let me use, I'll use blue. Okay, so I'm just going to rewrite this equation above. And let me erase that part. Oh, whoops. Oops. Okay, I don't want that. Okay, and the reason I remove parentheses, right, there's a 1 here. Well, 1 times x is still x. And here, I mean, there's a 1 that we don't write. Well, if we distribute that 1, 1 times anything is the same thing, so technically we've used the distributive property. Okay, so after removing the parentheses, usually we ask ourselves, can we combine any like terms? And we can, right? 2x plus 1x is 3x. And let me just do this one step at a time. Okay, we want to isolate x. I'm just changing my symbols here. So these guys, right, 3x and 49,000 are not like terms, but 49,000 and 116,000 are like terms, right? They're both constants, but they're on opposite sides of the equation. So I want to bring the 49,000 over. You can bring the 116 over, right, by subtracting 116,000. But I want to bring the 49,000 because I have an x on this side and I want to isolate that. So I'm trying to move everything away from it. So I'm going to add 49,000, right, to both sides. And again, that gives me 0, and I get 3x equals, and then if I add these guys, I get 165, right, 165,000. So 3 times what number gives you 165,000? Well, you would divide by 3 because you want to isolate x, right? Or you're really multiplying by a third, right? This is really a 1. So x is equal to, if you divide this out, a third of 165 is 55,000. Well, 55,000 what? Well, dollars, right? Because we're talking about average yearly salaries. So what did we say x was? What was our, whoops, our unknown? And our unknown was the bachelor's degree. Let me just get this red pen, or blue. So this is, right, I guess you want to say average yearly salary of somebody with a bachelor's degree. So now let's find the average yearly salary for someone with a master's degree. And let me just move this up, and oh, not sure what's going on there, but okay, I need some white space. Okay, so we need to find our master's degree. So our expression from step 2 was, so from step 2, okay, we know, right, 2x minus 49,000, right, that represents the average yearly salary of somebody with a master's degree. So we know what x is, right, we just found it above, so we just input that. So 2 times, well, the average yearly salary for a bachelor's degree is $55,000, and then we subtract 49,000. Well, if we multiply 2 times 55,000, we get 110,000, and then after we subtract 49,000, we get $61,000. So somebody with a master's degree, right, earns about $61,000 a year. And I believe we have another step, but I'm having trouble moving this around. So I'll just, well, you'll see, you have step 5 on your page. And step 5 basically says, does this make sense? Well, if you add the 2 average yearly salaries, so if you add 55,000 plus 61,000, right, do you get the 116,000 that we had in the problem? And we do, right? This is again the bachelor's, and this is the master's degree, right? If you would have obtained, negative 55,000, for example, negative 55,000 for a bachelor's degree, then something would be wrong, because you're getting paid, so it should be a plus sign, not a minus sign. A minus sign would be when you're paying an institution, for example, such as Kirkwood, to get an education, but here you're making money, so these guys should be plus signs. And okay, so that's example 1. Look for example 2 in the folder, and example 3.